Now we shall see the problem which is given under exercise 3.5. First problem we are going to see. Two different subdivisions are there. First subdivision is asked us to solve again. What was given? Sin square x minus 5 sin x plus 4 is equal to 0. See, the higher power, it is a 2. If the higher power is 2, we know it as quadratic equation. But a trigonometric ratio is involved there. I am going to replace the trigonometric ratio as a variable. Any variable we can take. I am taking as y. So put y is equal to sin x. So what happens, ma'am? So this become y square minus 5y plus 4 equal to 0. Find the sum and product for this. 4 minus 5. 1 into 4 is 4. Minus 1 minus 4. Okay, minus into minus plus. Okay, good. We can write the factor as y minus 1 into y minus 4 is equal to 0. That is y minus 1 equal to 0. Y minus 4 is equal to 0. What is y? Y is nothing but sin x. Sin x minus 1 is equal to 0. Here it becomes sin x minus 4 is equal to 0. If we equate this, what happens? Sin x is equal to 4. I am going to conclude answer as is not possible. Why? What is the reason? Already in 11th we have studied that the maximum value of sin x can be plus 1. So sin x is equal to 4. We are getting a value to be 4. Here it is greater than 1. So I am concluding it as not possible. So what about this sum? We can write it as sin x is equal to 1. 1 value is possible in case of sin x. So I am going to write this in terms of sin x is equal to sin y. So by using a general formula, we can obtain the answer by generalizing it. So 1 is nothing but sin 90 degree is 1. Since in the left hand side I have sin, I am finding a value for 1, or I am writing 1 in terms of sin ratio as sin pi by 2, principal value pi by 2. So sin x is equal to sin pi by 2. So we know that if a sin x is equal to sin y, generalization, if sin x is equal to sin y, x is equal to n pi plus minus 1 the whole power n into y. So by using this, I am going to write the solution as x is equal to n pi plus minus 1 the whole power n into, compare in the place of y I have pi by 2, where this n belongs to integers. Now this will be the solution for this problem. Now we shall see the second subdivision. It is given as 12x cube plus 8x equal to 29x square minus 4. First I am going to arrange it as a polynomial function. So what we can do? 12x cube minus 29x square plus 8x plus 4. Just I am arranging everything to the left hand side. So how to solve this problem? Already we have studied about trial and error in your 10th standard and in exercise 3.3 also. So by trial and error only I am going to solve the problem because it is a cubic equation. So first I am going to take a root to be 1. Instead of x I am going to substitute 1. So what happens? Wherever I am getting x, just replace it as 1 and you check whether you are getting answer as 0. So 12 minus 29 plus 8 plus 4. So if you simplify this, I am getting as 24 minus 29, which is equal to minus 5, which is not equal to 0. Only if it is equal to 0, I can say 1 to be the root of this given polynomial function. I am not getting. So just as a try, next trial, I am going to take 2. So what happens? 12 into 2 cube minus 29 into 2 square plus 8 into 2 plus 4. Just to simplify, 12 into 8 minus 29 into 4 plus 16 plus 4. So 12 into 8 is nothing but 96 minus 116 plus 16 plus 4. 96 plus 4 is 100 plus 16 is 116. 116 minus 116 is 0. When I am substituting instead of x to be 2, we have obtained 0 as the answer. So by the theorem we know 2 will be the root of the given polynomial function. So I am going to write x is equal to 2. X is equal to 2 is a root of the given polynomial. So therefore x minus 2 is a factor of the given function. So now what happens? I have found out one of the root. The given problem is a cubic equation, cubic one. So it will have definitely 3 roots. One of the root is ready now. So remaining 2 roots we have to find out. So how I am going to find out the answer? By a synthetic division I am going to find out the answer. How to apply a synthetic division here? See, the coefficient of x cube, what was it? 12. Coefficient of x square minus 29. Coefficient of x 8. The last term is constant. We found out one of the root to be 2 here. So I am using that. Initially we'll take 0. Already we have studied this sum. So 12 plus 0, we have to add these two. 12 plus 0 is 12. 12 into 2 is 24. When you are adding these two, it is minus 5. Minus 5 into 2 is minus 10. When you are adding these two, it is minus 2. Minus 2 into 2 is a minus 4. Minus 4 plus 4 becomes 0. So I can write this as a quadratic equation because one of the root is ready already. The remaining part I will write as a quadratic. So 12x square minus 5x minus 2 equal to 0 will be the quadratic part there. Now we are going to check for the sum and product. What happens? 12 minus 2, that is minus 24 minus 5. 8 3s are 24. Okay, good. We have minus. So if I take a minus 8, minus 8 into 3 is minus 24. Minus 8 plus 3 is minus 5. Okay, good. The coefficient of x square is not 1, it is 12. So by splitting off the terms, I am going to write it as, I am going to write minus 5x as minus 8x plus 3x minus 2 equal to 0. Now from these two I can take 4x is common. What will be balance? 3x minus 2. So again here it is 1. So 3x minus 2 equal to 0. If I take 3x minus 2 as common, from these two terms balance is 4x plus 1 equal to 0. Now equate separately. 3x minus 2 equal to 0. 4x plus 1 equal to 0. That is 3x is equal to 2. X is equal to 2 by 3. Here 4x is equal to minus 1. X is equal to minus 1 by 4. So what are the solutions? The solutions are, what are the solutions? The solutions are, already we found out 2. Now we found out 2 by 3 and minus 1 by 4. With this the problem gets over.